Hello guys, welcome back to my channel. This is the last video on the Python Pandas series. As you all know, we have done a lot. We have tried. We have gone through this Pandas series, rigorous learning, back and forth. But regardless, the main aim for us is to understand the Python fully, and then Pandas, and then I hope we'll be able to implement it in every area of our lives in data analytics. But this is just the first step in becoming data analyst, a data analyst rather. So uh, we'll also, as we know, our next segment is the MySQL. Then we'll jump on to the rest others, the Excel, the Power BI, and then the Tableau. But for now, this is the last video under the Panda series, and then I really want to appreciate y'all. It's not easy. We've gone through back and forth and all of that. It's not easy, and I hope you will be able to implement it. So today we'll be taking the um, a customer segmentation data set, a customer data set. We'll be doing a lot. Applying all what we've learned so far in the Panda series, and we'll be going through many things, new things, a little bit new things I might have not thought in the Panda series, but I'm just giving glance at them and not really dive deep. So this will help us to know how to implement them in every area of our data analytics life. Um, I'll stop at the very basic. You get the very basics of this data analytics. I won't dive too deep. We will dive deep into exploratory data analysis when we are done with other tools we use. Do you get what I'm saying? That time we'll be talking about the future engineering, but that will be the wrapping of the whole playlist. I'll use it to wrap. Then I'll also teach. I also dive deep into MySQL after we've gone through the whole tools, the MySQL, the Tableau, the Power BI. I also dive into tough MySQL problems for us to solve. So that's by the way. I'm just telling you. So for now, we'll just talk about the I can should I call it the intermediate level, or it's an advanced level although, but we're not like diving deep. I'm going to teach you how futures engineering, but that will be for those who stay with me to the end of the playlist, to the end of the whole tutorial, to the end of the whole bootcamp, till the bootcamp ends. So stay active, stay active at all times. Just make sure your notification panel is on, so you can receive updates from me. You can receive new videos faster, notifications on new videos. So today we'll be taking the customer data set. Um, as usual, we import our pandas, import pandas as PD. All right. Then we import matplotlib. That's the pandas library, Python library as well. Matplotlib, matplot library dot pyplot as plt. Okay, we import SNS, import seaborn as SNS. All right, we also import numpy as np. We'll run this. All right. So these are I name my data frame. I use df as usual. So say pd dot read underscore csv. All right, and then we'll get the link to the path to my data sets, which is this. All right, and then we'll call my data set df. Okay. All right, we're looking at my data set. Okay, it's not showing all the columns because if you want to see, these are all my data sets columns, df.columns. So if you want to display all your data set columns, this is it. And then you run it. Can you see all my data set columns? We have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I don't know, 39 columns, right? Shown here. We have 39 columns, and then we have 2,205 rows. So we want it to display the whole columns. Can you see it's not displaying the whole 39 column? So what do? We say df, say pd dot options, set option as display dot maximum columns, and then set this to none. Oh, sorry, set this to none. Alright, and this should be it. Now df So there's no such keys. I'm coming. Why am I making a mistake? Oh, I wrote display. Sorry, it's display. Display. Alright. This also for rows because I want to see all my rows as well. Well, it's not really necessary, but I just want to see all my rows. That should be it. And then let's should display everything. Why is it taking time? Alright. Can you see? I display the maximum rows. So have this at the back of your mind as well. And this is the maximum column. So this syntax is a set option syntax used to display maximum rows and maximum column. Do you get what I'm saying? So I use it a lot. So keep that, note that. Do you get what I'm saying? Then for the next thing, let's check. Let's see how data frame df.info. I want to see how my data frame looks like. Tell me everything about my data frame. Alright. Shows 2205 non-null values for income. So for every column there are 2205 non-null rows. Non-null value rows. Do you get what I'm saying? Then data type for income, float, integer, and the rest of that. So everything is looking stacked and well nice. And then what do we do next? We look at my data frame. So we have information about it. Now first thing first, we check for duplicates. We don't want duplicates, alright? So we have to like remove duplicates, and then we'll check for non-useful columns, alright? Check for non-useful columns. You remember how we do our exploratory data analytics. So first thing first, let's drop duplicates. Drop duplicates. Alright. In place. It's true. This should do it. So you see number of rows should reduce. We're having 2024. I'm just showing this. Are we sure we did what we did right? Is there anything I've not done? I think there should. Are you sure there are duplicates here? Not bad. Let me do something like this. df df dot drop duplicates. I think it's good like this. Let's see. Let's try and run it. Okay. If it doesn't drop duplicate, alright. Probably it has dropped the whole duplicates. Oh, as you can see, we have 2220, 2200. That means in place worked as well. It dropped duplicates using that in place. True. So there are like two ways you can do it like this, or you can do it like this. Please, I'm sorry. See, if you do not want to equate it to the data frame, you can just write in place true. You know about this. Alright, so there are two ways. So I'll just highlight. So I'll make this one a comment and that, so you know about that. So as you can see, 2200, 2202. We removed 2201, which was initially there. So what do we do next? We look at our non-useful columns. Okay, we will scroll through all our columns and then look at the non-useful ones, and then we'll see if we can drop some non-useful ones. Okay. Okay, overall, camp overall, I think this is useful. You have the main sports and all that. Z cost contact, Z revenue. Uh, are they really necessary? They are the same thing. I don't think they are necessary. So these are columns we have to drop. These are columns we have to drop. These are columns we have to drop. So df the drop. Alright. So columns should be equal to z what? Z Z cost contact and then Z revenue. Let's copy this. Copy this. Sorry about that. Why didn't this copy? Okay, copied. And then our Z revenue, which is this. Let's make sure it's always being dropped. Let's go back our D. So we should see it should reduce. Should reduce, so should have dropped here. Should drop it. Should drop it. Should drop it. Should drop it. As you can see, it's no longer here. As you can see, it was after complaint. You have the Z. Here you cannot find it. After complaint, you have response and all that. So that's it. That's literally it. What do we do next? We'll check for null values. Let's check for null values for in our data sets. We check for null values, and we check for unique values as well. So let's check for null values. Yeah, sorry about it. df dot is null. Alright. Dot sum. Okay. So it's not forgot to put this. Check for some of null values. Okay, as you can see, in every column there are zero null values, so we are safe. We are good to go here. So also check for unique values. So we say df dot n unique n unique. Alright. In income there are 1963 unique values. In kingdom you have 3 unique values, which is you can use that for something. You use it for the group by option and all of that. And then the teen home 3, you have 100 for these. Alright, everything is looking well good. Everything is looking good. So this one is you have two unique values. Maybe they just have 1 and 0, yes or no type shit. So it's looking well, it's looking nice, looking very, very, very sexy. What do we do next? As you can see, it's just about like scrolling through your data frame, looking at what is needed and what not, and what you do not need, and all of that. So just scroll through your data frame. Basically, just doing everything you want to do about your data frame. So what I want to do now is to list my. I want to list my data frames that contain so my data frames that have I think what do you call it? My data frame that contain amounts and then income. So I want to state all data frames that have actual values you get. So check for the income. Let's look at how they can be correlating and all that. So let's see. Let's just scrolling through my data frame, looking at what is necessary. Alright. When you want to list more than one columns, remember I told you use double brackets. So it's very important. So income, 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 and then you have the amounts, and then we look at all the amount values. Okay, amount on wines. Looking at it from here, You can see amount of wines, amount of fruits. Do you know what I'm saying? Amount of fruits. Alright, then we have amount of meat. So I'm just scrolling through, I'm just looking at how my data frame would look like. Products. Alright. Amount on okay, I can literally just go back here and then copy them instead of, let me just copy from here. Can you see? Copying from here to think here. Looking at amounts. This should be good. This should be good. Are there any amounts? There's also amount on total, amount on regular pods. So where let's just go and paste. So it's now time. Alright, is there another thing? So amount total. As you can see, I'm just like scrolling through all my data. Do you get? No, nothing special. Is there any amount? Check. Think amount on regular pods, on regular products, amount spent, the amount spent by customers. So just looking at just the amount spent by customer, how correlated they are. So I think I'll put this here. I think I'll leave this here. Let's just see how it looks. Alright, so what he returned. Returned these. So these are like my amounts data frame. So that's all. Nothing special. I just want to look at how my data frame should. So what next? What next? I think I should jump into looking at my data frame. I'll show what it returns. Just going to my data frame, checking what. Let me see. I've seen something. Age. Alright. Age. And then this complaint as well. My use it is necessary because there may be complaints from one or the other. But since it's returning 0, they're giving the same vibe. I need to complain 0 and 1 to know the response 0 and 1. Okay, for this age, let's see my age. So since it's just one column, put one straight. Okay. Oh, sorry. See me. Sad. At this age in time. Alright. See, we have unique. How many unique in age? Literally, if you go to age, you have 56 unique values. So there are 56 ages. And that means the highest here should be like 56, if not. Okay, not necessarily 56. It means like 56 unique ages. And it's from 1 to. There are 56 types of ages that are in here. Age 1, there's no age 1, so we're probably starting from age 20 or age 18, that kind of thing. So there are 56 different type of ages. There are 56 different ages here. So what do we do with this age? We can use this age for many things, very many things. Alright, so I said we can use this age column for very many things. So first thing first, we have to like group our ages. So let's go to age grouping. So let's start taking notes. Age grouping. So how do you group ages? I want to like segment my ages into what do you call it? Probably the young adults, the elderly, the old and seniors and all of that. So I know how to group my ages. So I have to like section my ages, that kind of thing. So we'll check. So they have alright. So we're creating a new column in it. Do you get what I'm saying? We're creating a new column, age group, named age group, so that we can use to group ages from the age column. Do you get what I'm saying? So first thing first, let's say our beans. So I have what you call beans. Beans is like the section of the ages. Do you get what I'm saying? From 18 to 21, or sorry, 18 to 24, probably 24 to 35, 35 to 45, 45 to 55, and then 55 to 65, and then 65 to the end, because they are like elderly. Do you get what I'm saying? So we'll state our bins. Do you get what I'm saying? Our bin should be said 18, 24, 35. Okay, 24 to 34, right? Then we have 35 to 44. So we'll write the next one. Then you have 40, you have 45 to 54, which is 55 right here, and then 65 to 55 to 64. And then what's the last one? We want to like take it to the infinity. So right, integer, since it's integer, do you get is an integer value, yes, of the infinity. So to probably 2 million. That's nice. That's nice. So that should do it. Then our sectioning. We call it our sectioning. We call it our label. Sectioning. So these are like is a way of like grouping my data into, do you get sectioning, or should I call it labels? I'm call it labels. So this will label it. So we say 18 to 23 should be what? What should you name them? Um, Youth. No, sorry, above youth. Upcoming. I'm just naming them upcoming. I'm just naming them anything. Posting. I'm just write posting. Alright. Then the second one is the young adults. Young adults. And then the third one should be the middle aged. So and then this one, that's from the middle age is from 35 to 44, and then from 45 to 54 should be the seniors, and then the elderly should occupy the 54 to 55 to 64 of the elderly, and then the old. Are we? Am I? Let's see. Posting 18 to 23, 24 to 35 should be the young adult, then 35 to 44 should be middle age, 40, yeah, 45 to 54 should be the seniors, and then 5 to 64. So seniors, do you get what I'm saying? So we have like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's it. So let's see. Then is that all? So that's all right. Now our sectioning now starts. We have DF, our age group. Okay. It should be equal to the DF age. Are you following? So we want to take the age column, the age column, and then section it into age groups. Do you get what I'm saying? So what is that function we use? Once we take the age column, then section it into into like age group, different age group. What will we do? Let's write our df.age. So then we have to cut it. pd.cut. pd.cut. Okay, are you following? And you cut this into bins, and then labels. Are you following me? And then labels, and then we'll include the lowest as the smallest. Include, let's go lowest. Okay, so I think this should do. The age group. I think this is it. It's an invalid. For infinity. Okay, I think I know what this is. Let's see. I think I know where the issue is coming from. So, alright, that's nice. So section did, and then returned the age group with the labels. Alright. And to see where the issue is coming from. Okay, there's no issue. There's no issue. Why is the writing point 0? It's because of that float. It's because of the float. It's because of that. Okay. I'm sorry. I think I see where bins and then labels should be equal to labels. This should do. So bin labels must be one fewer than the bin edges. Alright. Oh. I see. So the labels must be more than. So labels, yeah, bin labels must be one fewer than the number of bin edges. Okay, the label should be more than that. So from saying this is 1, I think 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Okay, so this should be yeah. So let's now go through it. This is the posting 18 to 23, young adults 24 to 34, middle age 35 to 45, seniors 45 to 55 to 54, elderly 55 to 64, and then the old 65 to infinity. So that's it. That section is. I forgot to equate it, like assign bins to the bins. So I should have labeled it another way. So we assign bins to bins, and then assign label. Let me give this another name. Bin. Let me just mention bin so you understand what I'm saying. Bins, and then section. Like I said before, sections. So you assign bin, bins, alright. You assign sections, alright. Still the same thing. So do you understand now? So that's how it is. Alright. So now we have partitioned it, and then we'll now look at our data frame. Let's see if it added it, so we can use it for visualization. Now 40 rows, can you see elderly, old, seniors, middle-aged. You have seniors, and all of that. So that's that about that. So now we have partitioned it. So we have to now work with this age group that we already made. So there are many things to do with the age group. When you look at our data frame, we'll check the age group that ends the highest, the age group that have the highest average income. Then we'll rank them as well, and we'll see how it goes. And we use there's what you call the head syntax and all of that. So now we want to rank the age group by their income. So we say ranked age group by average income. Okay. So say ranked age group by average income. Alright. So this should be it. This should be it. And then what do? We check our age group, df age group. Alright. Do you get what I'm saying? Then we group by no. We want to group by age group. So we say df dot group by okay. Do you get what I'm saying? So we are grouping by the age group and then we are now ranking it by the income age group, and then we rank by the income, by the average income. So income dot mean, I taught you this. Alright, dot head, or should we sort value? Because I want to like show the top 5. Head will like show you the top 5. No, this is not it. So to frame, so I'll sort it rather to frame, and then we want to now rank it. Dot sort values by income. Alright, and then so we said sending false. Let's see how this plays. Let's just see how this plays. Okay, it worked. So this worked. This sorted the values by income, the average income, and then you can see that the old people ascending, that's descending from the top to, as you can see, the old people earn more, the elderly, and you have the seniors, and then this is a little bit fucked up because we are meant to have the old ones anymore. As you can see, posting have the list. Do you see what I'm saying? Are you seeing what I'm saying? Posting have the list, which is weird, but all in all, it has showed us what we wanted to see and all of that. So as you can see, we have worked with the age group. So now let's create a visualization for it. So we'll plot a histogram. Okay, plot a histogram or a bar chart. So that will tell us how it looks like. Let's plot a bar chart. So let's take this. Let's plot. Okay, I see what I'm doing. So say cancel bar. Or should we use horizontal bar? No, I think bar is okay. But horizontal bar will be nice for real. Let's use bar H. Okay. Then the X label should be, so this is inverted, so X label will be the income, average income, and then Y label should be the should Y label be Y label will be the age group. Alright. Title. We need title. So it should be age group by copy this. So is there any other thing we're missing? I think I'm good to go. Should put it well. Alright, as you can see, it arranged it. So it has done it by average income end. So that's one phase of the EDA. So our next phase now is to check the amount. Do you get what I'm saying? The outliers of the amount. Do you get what I'm saying? So we have to check, identifying, find outliers. Okay, that is sad. So what are outliers? I'm sure you have heard it when they said, you have heard it somewhere, even when going through your statistics notes, and somehow you learn about outliers. So outliers they are they are like values. They are used to calculate values that are within three standard deviations. You get anyone that is below or above the three standard deviations would be considered an outlier. Do you get anyone within it is not an outlier? So outliers, they exist outside. Do you get what I'm saying? So we use a box plot. It's also called a box. It's called a box plot. The visualization used to identify outliers are called box plot because they exist outside the 75th percentile and then below the 25th percentile. Do you get what I'm saying? So that's what we call the interquartile range and all of that. So let's just take small note on it. So just a little note on it. So I'll just give you some notes on this. Alright. So outliers. After identify outliers. So outliers, we say outliers. I'm giving you this from my head. Outliers are used to calculate. They're used to calculate values that are within three standard deviations. Deviations or the interquartile range. So this interquartile range is the plus or minus 1.5. So that's the formula. I'm literally giving the formula, then multiplied by the interquartile range. Do you get? So on the interquartile range. Alright, then so literally this approximately three standard deviations. Alright, so what do? We use it to they are used to normalize distribution. The distribution of a data set. Alright. So as you can see, you can now read it for me. So now, do you get what I'm saying? So now let's calculate our outliers. You get? So our first quarter. So our first quarter should be DF. So once you check the total amount spent, do you get? Like within the ranges, we are checking our outliers on the amount spent. So we just literally go to amount total because there is a column for total amount spent. So I see amount total. Just go and check the column. Income. This should be amount total. Where did I find that? Total amount. I saw it somewhere around there. Shouldn't be far from here. Oh, it was around this side, yeah. You can see total amount for this, for this, for this. So these values are wide gaps. You get, so we have to calculate the quartile ranges, the ranges. So there are some amounts that are fast spent outside, there are some amounts that are fast spent within or below. Do you get what I'm saying? So it helps us to show distribution. Do you get what I'm saying? So it's the amount total. So tracks the distribution of the total amount spent. Do you get what I'm saying? So of the quarter. So use the quanta keyword to calculate the quarter. So for the 25th 25%, 0.25, okay. And then third quarter. Third quarter should be alright. Don't forget quarter. Okay. Then now we have our first quarter and our third quarter. So now we need our interquarter range, which should be like the difference between the third quarter and the first quarter. Okay. So our interquarter range. Which is the difference between the third quarter and the first quarter. Third quarter and the first quarter. First quarter. Okay. And then, so what do? We check our boundary. Our lower class boundary. If it's below it, is an outlier. If it's above that, our upper class boundary, it is an outlier. Do you get what I'm saying? So our lower class boundary. Lower class boundary should be the first quarter. That's like 3 standard deviations quarter minus 1.5. So if it's below it, if it's below this 3 standard deviation, 1.5 times the interquarter range times this. So if it's below it, it's an outlier. And then if it is above, I can just copy this and paste. So Z, sorry about that. Then we have a higher class boundary. Change this to higher class boundary. This is the third quarter. Third. Then this should be plus. So if it is above the third quarter, it is also an outlier. So are you understanding what I'm saying? So now we'll now check our outliers. So outliers, we say value. Let me make a note here. Values above the class boundary, above or below let's say values are below the lower class boundary and above the higher class boundary. So those are outliers. Do you get what I'm saying? So yeah. So check our total amount where it is greater than the lower, where is less than the lower class boundary, where it is less than this. Check our outliers, our total amount where it is less than this, or where it is greater than this. Use or. Do you get what I'm saying? I hope you understand what I'm saying. Think yeah, something like this. Just copy this, then use the greater than. Okay, so greater than the higher. H GH. Higher than the, yeah, these are outliers. Do you get what I'm saying? Then return it. Okay, so mention our top outliers. Close those head. Our top 10 outliers. Top 5. 5 is okay. So series of the other quarter. Oh, sorry, this is quanta. This quanta. Yup. So returns are, can you see? This will return the whole table, the whole table, the whole DF table you get where it is greater. So you can now go to the amount, total amount. Amount total, can you see? This one is greater. It's not mentioned. So there are just three values that are outliers here. So there are just three values that are outliers here, which are actually below the interquartile, because if you check for um, the lower clause boundary, let's check for the lower clause boundary. No, let's just check. Let's see what our lower clause boundary is, so that you understand what I'm saying. And then higher class boundary. Higher class boundary. Can you see? Our lower class boundary is minus this, and then our higher class boundary is this. Do you get what I'm saying? So the values below this are none. Do you get what I'm saying? And then value higher than this are like literally. Do you get what I'm saying? So that's just the meaning of outliers. So any value you see that exists below this range is an outlier. So any value that surpasses this range. So outliers that we can see here are 2429, 2491, and 2429 again. So that's literally how you calculate outliers. So it's just literally simple. Nothing is hard. It's coding. So do not be scared of coding. So now we want to remove our outliers. What do? We delete them. Do you get what I'm saying? We delete them. We check where they are they are not useful. Do you get what I'm saying? So to drop them, I don't want to alter my data set. Do you get what I'm saying? I don't want to alter, or should I alter? So let me, I don't want to alter my data set. So I want to like create another data set that returns only what. Do you get? So write df normal. Okay, do you get what I'm saying? So we have this. Let's just copy this. You know this is or. This is or. So this one is for or. Now we'll return it where where it is greater than the lower class. Are you following me? So we're returning this total amount now. We're returning this total amount. We want to remove our outlier. Our outlier said the ones that are less than the lower class boundary and greater than the higher class boundary. Now, we want to return the normal data set. Removing those outliers is now putting our data frame within the range where it is within the lower class boundary and the higher class boundary. So greater than the lower class boundary and then less than the higher class boundary. So that's just it. That's literally it. And then we use and. Note, we use and then return our df normal, our normal data. Alright, this is our normal data. Can you see? It has removed 3 rows from what we were having before. Do you get what I'm saying? So now, if you now check, if you want to describe df the normal, so this normal we can now export dot describe. Now if you do a box plot of these outliers of the normal one, you will see that. So if you do a box plot of the first one, like if you want to plot a box plot now of that first one, you will see the outliers. But if you do not, like if you now plot a box plot of the new ones, you will not see outliers. Do you get what I'm saying? So now let's plot a box plot of the old one. Say kind should equals to. Are you following me? So that we can spot the outliers on our oil label on our box plots. Alright. So I'm just using shortcuts. Okay. Can you see? These are see them, the outliers. They exist. They do exist. Do you get what I'm saying? And then there are some that are above. You see them. This thing is overlapped. It's not really plotting into it. But now if you plot the normal, you can now see that even with this describe, from this describe you can see everything is within the range. Standard deviation. You go to the total. Total. I'll find total. Okay, shit. Standard deviation, everything is within 5,000. Okay, this is the standard 550. Also, yeah, standard deviation 1,000. Then the mean and all of that. 25%. Can you see it's 50%, 75%, everywhere is okay. So the maximum here is 2,259 within that range, within the upper boundary. 2,200, this is the higher class boundary, 2,322. So the maximum is there. And then did they return the minimum? What is the minimum? The minimum is the fourth line, minus 283, which is within the normal range. Can you see minus 283? This one now is minus. This is the lower class boundary. Can you see it's not below it? Can you see? So let's check box plot of DF normal. It's a little bit different. It's not really showing what I want. It's not really showing. Can you see there are like some outliers here? It's not really showing what I want. It's not really giving what I want. Let me use SNS to plot it. Okay, plot with Seaborn. So to show the outlier as well and all of that. So you guys should just do me. SNS dot box plot. So that's the one I imported. That's one reason. So I should be. And then we use PLT from matplotlib to show it. Sorry about this. My column. What did I do? Should be one. Let's see. Okay. This show can see no outlier here. Everything is within that range. Can you see within this box? Everything is within this box. So that's literally how good it is. But let's try and see if we can plot this. Can plot this. Let's df. Let's just see. I see. You have two outliers, and it should be three self. Okay, because one is within this. Can you see these are outliers? Do you hear what I'm saying? So what do we do next? Now we have done a lot already. So the last part of this EDA should be our correlation. So we should be able to correlate our amount spent. Let's see how correlated they are. So amount spent, correlation and all of that. So correlation between amount spent and income. Let's include an income. So remember we stated some. Sorry, not tell you about why I stated them. But remember we did something like this. Okay. So alright, this is nice. Okay. Sorry, there are times I will not be talking. So I named this DF amount. So I want to now correlate with I want to show you the correlation with SNS as well. So we'll do the heat map. Okay. And the heat map should be DF amount. Then we'll correlate it dot CORR. This is it. So that's how correlation works, and then we'll show you the annotation. I taught this before. I taught this before. And then this is our let's use Inferno this time. There are many times there's what you call blue cool one, there's this blue flame, and this is Inferno this time. So this one is actually nice, shows you how correlated they are. Then we use PLT from Matplotlib title. So what do we do? Title show correlation between amount spent on income and correlated they are. And what are we saying? Go to the show. Okay, as you can see, these light ones have higher correlations of one, income with income, and then we have amount of wines, and then as you can see there's a high correlation between income and then amount spent on wines. Also amount spent on a fair correlation. The lowest correlation here is the amount spent on good product, because you can from here say that people do not earn enough to afford good products. You get sweet products, fair, and then total amount. In total, people spend a lot on expenses. They spend from their income a lot on expenses. As you can see, you have high correlation and all of that. So I think, what do you want me to see? Literally nothing to do again. I think I'll stop here, or let me look at my data set again. Let me see if I'm missing anything. Look at how my data set is and see if I'm missing anything. Can't really tell. Counter. So I think we have done the main things on this exploratory data analysis. So I'm giving you an assignment or what to do on this. So you go through the data frame, you check what and what can I talk about on this. Let me give you an hint. There's a column here named purchases. All right. So as you can see, number of websites. So you can check the total frequency of purchases. There's purchases from deals, purchases from web, purchases from catalog. So the total purchase, you add all this together, you check. Also, you can correlate income, age, and then amount total. Do you get to show the correlation between the income, the age, and the total amount? That one too is fair. That one is fair. You can also do that. I want you to go and do that, and then you use another correlation, another heat map style. Do you get what I'm saying? That one too is fair. So, but for now, I think I'll stop here. And the video is getting too long. But we've talked about the main things. You can also enter customer segmentation, and then later on we'll go through others and other things we have to do on Python, Pandas, because there are a lot of things to do. You can also talk about educational status and all of that. These are various things you can learn. I told you, like I said, you can also say customer, the amount they spent, total amount spent on education, higher educational status. So, but me, I have to stop here. I've shown you the basics, and you can go ahead and do other things you want to do. You try out, you test, you go through other things, you find out new things, you dig in, you grow, you learn, you do other things, and this is the end of our Python series. Do you get what I'm saying? So enter educational status, enter professorship. You can see there's what you call professorship here. I think check if it's a professor. I think PhD, yeah. I think I worked on that. Graduated, all of that, basic and all of that. You can work on them, work on various things. Go ahead and play with the data, check total amount spent on the educational status of customers and all of that. So average income on the you can rank the income received by people in the educational status. So and all of that. So check, you can check. Let me walk you through some things. Check marital status as well. Like it's really fun to, I mean, go through the data, have fun with the data. You check, you get segment your data into professorship, master, just a simple graduate. Then you make a bar chart, you rank their income as well. You can rank their income with bar chart or histogram, various things. So I'm giving you hints, so just go ahead and play with your data. That's all. I can't tell you everything, but at least I've laid down the basics for you, where you can do your thing, you can enjoy, and then do a lot. So thank you for staying. Thanks.